So this section, I want to start with talking about saturated versus unsaturated. So unsaturated is used to describe an organic molecule that does not contain the maximum number of hydrogen atoms. And I ended off here, I think, with previous lecture. I'm not sure. I don't remember now how much I went into that. But I thought I had, there we go. Here's my blank screen. I think with, probably should have gone back and looked at the last lecture. But what I talked about was naming of the alkanes, and I think I briefly talked about alkenes, kind of in a hurry, and the double bond is always designated where it's at. Okay, so for this example, it would just be propene, because it doesn't matter if you put it here or here. It's going to be on the first carbon. It's the first carbon from this end or the first carbon from that end. But if we were to make this a 4-carbon structure, again, it's, well, this is the same no matter which way you start numbering, 1, 2, 1, 2, but it's 2-butene, because we could also have a 1-butene, okay, or one butene. See, it's the same. So these, all of these versions of butene are unsaturated. And the reason that is because this carbon bond right here means that there's not as many hydrogens as possible around these carbons. Remember, every carbon can take 4 bonds. So let me put butane up here real fast, the alkane. And that would be a hydrogen, that would be a hydrogen, that would be a hydrogen, 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 and 3 hydrogens there. Okay, so all of these dashes would have hydrogens on them. Okay, not going to draw all those, but they're all going to be hydrogens. Here we have our standard 3 hydrogens on the end, okay, because that's 4, 1, 2, 3, 4 bonds, and same over here. But this gets tricky in here where this double bond is, because now we've got 1, 2, 3 bonds. So we're going to have a hydrogen here, and the most common way to draw that is to not stick another hydrogen up here, but to put it opposite side. Okay. And here we get into just, I think that's kind of just convention, so that things don't get so crowded up here if you're trying to put hydrogens. But anyway, your problem is that there could have been hydrogen here, and it could have been hydrogen there if this were a single bond, see, like over here. So the idea is that one of these bonds, maybe you can think of it this way at least, these bonds, one of them could be broken, and we could cram some more hydrogens on here, and then it would be saturated. Okay, saturated and saturated. All right, kind of a simplistic explanation of that there, but that's roughly in a nutshell, okay, our terminology there. Let me get back to the, well, I think I do have to erase it next. I'm back to the definitions. So where you've probably heard the term, oh, hey, I can do a clear all, I think. Yeah, there we go. Okay. Come on, advance back, give me back my, there we go. Where you hear saturated and unsaturated often is in oils. We talk about polyunsaturated, meaning that it's unsaturated at many locations, more than one double bond. And to be unsaturated, it requires just one double bond to be categorized as that, but you can have many multiple bonds, many of these double bonds that cause something to be referred to as unsaturated. So your alkenes and alkynes will all be, everything except an alkane is going to be considered saturated. Okay. I mean, sorry, the alkane is the only one that's going to be considered saturated. Everything else will be unsaturated. So I said that backwards first. Where you hear about this though in the oils, and what that means is that uh, the chains, usually it's kind of the fatty acid chains hanging off the glycerol unit have a lot of uh, double bonds in them that could be persuaded to take hydrogens. Oils are unsaturated. That gives them their uh, liquid at room temperature property. Animal fats are saturated, and that gives them their solid, or at least firm, uh, texture at room temperature. So think about your animal fats. You've got butter, you've got lard, you've got tallow from beef, and they're all solid. Whereas your corn oil, canola oil, safflower oil, sunflower oil, whatever vegetable oil you want to go after, is liquid in the bottle. So what happens is in the processing of these non-animal fat products that are solid, like margarine, Crisco, okay, those, they actually bubble hydrogen, at least the old way of doing it that was first invented, was to bubble hydrogen up through vats of this oil, basically kind of forcing these double bonds to release and take on the carbons, the chains to take on extra hydrogens. And this is where you have the term hydrogenated fat or hydrogenated oils. And so if you read on your ingredient lists for the vegetable-based solid fats, it's going to say hydrogenated such and such oil. Soybean and or cottonseed typically is a common one. Uh, um, partially hydrogenated, okay, uh, is the more common usage of that. And your Crisco will be a partially hydrogenated. I think it's soybean or cottonseed oil. They list sometimes a whole bunch of different oils that they could use to get whatever's cheap. So this is one of the reasons why some people look at the margarines and the vegetable fats that have been hydrogenated and say they're not healthy. They may actually be worse for us than butter as far as adding to arterial plaque, because these are substances where those hydrogens may bond are kind of sort of random as to which of those polyunsaturated areas are going to take on some more hydrogens, may bond in such a way that our enzyme binding sites to break those fats down may be messed with, and the body may not be able to break those products down as fully as they would if they were ingested in a liquid form or the oil form. Um, and then what happens to those particles that are not fully broken down in the digestive system? Are they absorbed into the body? Do they wind up in the bloodstream? Some studies indicate yes. And in that case, the body, they kind of just circulate around and they can deposit on the uh, arterial walls. They can get caught on plaque that's already there and just add to it. Um, more studies are indicating that the fake fats or the fake butters um, made out of originally liquid oils are not a good idea. So, uh, you know, jury's still out. Say, well, it's better than butter. Well, no, maybe not. The body can at least break down your butter and your lard and your tallow with enzymes we've naturally got in our system and break them down fully. That cholesterol may not be anything compared to the cholesterol your body's going to make anyway. Uh, so it's just there's a lot there's still unknown for certain. We have ideas. We think we have evidence to support one thing. We think we have evidence to support something else. Which way is it? Okay, but that's kind of a little bit of a controversy there, and that's what is meant by saturated and unsaturated. Uh, does that carbon chain structure have all the hydrogens it could possibly take, or are there double bonds that are reducing the maximum number of hydrogens potential for that carbon chain, that carbon number on that chain. Okay, so here's our alkynes. We have triple bond again. So you're going to start off with your carbon number, and you're going to put "-ine" on the end of it instead of "-ane" or "-ene." So exact same pattern we've already talked about. Nothing really new there. With a cycloalkane, what we do is we form them into a circle. Okay. Um, and so they're considered isomers but have different chemical properties. Um, let me see if I can refer you to a page in your book on this. Let me look over here. Should be referred to as like a cyclohydrocarbon, I think, in your book. And basically, the main one we talk about a lot is benzene, but that's going to be an alkene, and I think that's where that second one comes in there because it's got double bonds. Benzene, thus the ene. Well, there's a problem about it. So where have they introduced it? Cycloalkanes on page 339. So to talk about these, we've got name that alkane. Practice quiz. 1, 2, 3. Eth meth pro. Propane. Okay. So if we take standard propane, and we circle the wagons, we wind up with a three-sided triangular shape molecule here. Okay. And simply we put cyclo in front of um, anything that's had this happen to it. Okay. So we have now cyclopropane. And so butane winds up being a 4-carbon. So with that, you're going to get carbon, 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 carbon. Okay, cyclobutane. Pentane. And so these are often shorthanded like this. The points are carbons. You know the points are carbons. Okay, points are carbons. You know the points are carbons. And we know that hydrogens, unless specified, hydrogens are what's coming off of there to make the total of 4 bonds per every. So for every carbon. So we'd have, actually, if you wanted to draw them all out, you'd have like this and this. We don't do that. Not generally, unless we're trying to prove a point, or these are structures that have other things attached. Okay, that can begin happening, but right now we're just keeping it simple. So that'd be your pentane structure. And then we have the cyclohexane, which is a very common structure, and you're going to see it a lot. Okay, so that's cyclohexane. And then if there's nothing at these points, you assume there's a C. But what you'll find is as we go, you're going to find that I didn't want that done. Stop. Okay. I'm not going to try to erase that. You're just going to find that we have something like oxygen there instead. Okay, that makes it a whole different, it's not cyclohexane anymore. That makes it a different thing. Uh, but this is the base structure where we start basing this stuff off of it. Okay, so that introduces you to the cycloalkanes. And then let's see, what's my next slide look like? Does it let me go to it? Okay, yeah, so the next section then in your book, we're going to talk about the benzene ring. And let me see where it introduces benzene ring for you. I don't know that it does. It just kind of jumps to that, doesn't it? Well, it's got to somewhere. So the benzene ring is a 6-carbon structure. But now instead of being an alkane, it's an alkene. And what we have is every other side is a double bond. And well, that's showing up in chapter 10 with your alkanes. The benzene is. Um, so I think they'd introduce it in there somewhere. Hmm. Wow. Okay, so I'm not seeing it, but it would make sense to me to put there with the cycloalkanes, and then let's just talk about cycloalkenes. Build on it. But that doesn't seem to be what's going on because they in the chapter at that point. Okay, but then in the problems they've got benzene rings and the problems at the end of the chapter, so it's got to be in there somewhere, I suppose. But I'm going to well, I had the section a minute ago on aromatic compounds. Sorry, I should have got this all bookmarked before I started. So your nomenclature on how to name your alkenes and your alkynes is in chapter 11, page 358. Talks about that, and it's again, really just going to have to note where your carbon, your double bond is on your carbons. I do actually need to talk about some extra things about other groups being added in, like I did last time with the methyl groups. It's the same practice. Okay, so move on. Um, aromatic hydrocarbons is going to be the section heading in your book, and I'm not finding it here really fast while I was trying to go through here. But what happens is for benzene, we do this every other carbon, every other side, okay, has a double bond, and that allows for this carbon right here, say, to have 1, 2, 3 bonds, and then something can be attached off of it. Every carbon's that way. 1, 2, 3, something can be attached off. 1, 2, 3, something can be attached off. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, we can attach something on every single point of this single bond. Okay, so if we come over here and pull a single bond off of this, and instead of putting a hydrogen there, we put an oxygen. Okay, and then we can put oxygen needs 2 bonds, so we can put another hydrogen there. And instead of putting the bond like that, we usually don't. We just put the H. Okay. All right. Make it OH. That would be an alcohol group, right? I think I mentioned that with the alkanes. I may not have. We're not to that yet, maybe. Okay. So I'll come back to it then. That's your first hearing of that. So this benzene structure with a hydroxide group, hydroxyl, it's called a hydroxyl group. Okay, that is phenol. This is a compound called phenol. It's an aromatic, has a particular smell. Um, it's one that, once you smell it, you go, oh, okay, that's phenol, and you can smell it in things. Okay. Um, oh, it seemed like at one point I knew what compound it was. In Noxema, there's something in Noxema that has a very strong phenol smell, and it's a compound. I think it's got a phenol base. It's not actually phenol itself, but it's a phenol something or another, okay, or something phenol. But anyway, that that's one of the things that I learned to, or one of the first things I associated with phenol after I smelled phenol the first time. So I got, there's other things that give Noxema its scent, but for me, once I had the phenol, I picked that out, or at least there's something that smells very, two combination of things smell very similar to that. But I believe at one point I had done some research and found the ingredient on that. I don't recall now what it was. Um, Toluene is another one. Um, and it's got a methyl group attached. So instead of having a hydroxyl group here, there's a methyl group. So you can see some of these uh, aromatics on page 375 of your book. The only one that I might actually ask you to name is phenol, and I probably won't. Okay, uh, but they have these names instead of uh, the other name that could be given here is, this is a benzene ring, and you have a hydroxyl unit, so it could also be called hydroxybenzene. Okay, hydroxybenzene, and that could be, I could put it on the test for that reason, in which case I wouldn't give you both names as a choice option. I would give you one or the other. And I would probably go after the hydroxybenzene, since that's following the naming practice that I'm teaching you. Okay. Phenol is an older name before we adopted this more standardized naming practice by looking at units and where they attach, things along those lines. Okay. So that's when you could see, again, this, as it says here, this, let me just go ahead and clear these drawings here out of our way so we can read things. A benzene ring can also attach to other molecules, and it doesn't have to be the base molecule and have stuff attached to it, which can happen as well, but it can also attach. And when it attaches, then you get the prefix phenyl on it. Okay. Um, I don't believe that I have any questions, any structures on the test that I ask you to name that have that issue. Okay, have it as a phenyl. Uh, um, you've got to come up with a name. Okay, but I do want you to know that because you're going to see that a lot. If you go on into other chemistry classes, you'll see phenyl as a prefix a bit. So petroleum is a mixture of alkanes, cycloalkanes, and some aromatic hydrocarbons. It's got a lot of different things in it. That's why we can distill it down and pull different things out of it. So we get these hydrocarbon derivatives. Looks like I need an and there. Don't think it'll let me modify in this mode. Okay, formed when one or more hydrogen atoms and a hydrocarbon have been replaced by some element or group of elements other than hydrogen. So I was kind of alluding to that earlier. This is achieved usually with some type of substitution reaction. Unsaturated molecule can form a derivative by an addition. Wow, I really need to edit this. By an addition reaction resulting in long chains and large molecules. So the atom or group of atoms in an organic molecule that is the site of chemical reaction is referred to as a functional group. And it's responsible for the chemical properties of an organic compound. And so it can sometimes be these replacement elements and groupings of replacement elements to make it functional. So back there earlier, last slide or so, when I had that hydroxyl unit on the phenol, okay, that is a, or on the benzene, okay, to make it phenol, that's a functional unit. That hydroxyl unit is a functional unit. Functional units usually have multiple bonds or lone pairs of electrons that can cause them to be a reaction site. So the first one I want to talk about is that hydroxyl unit. When put on stuff, that makes an alcohol. Okay, so when we name our alcohols, the name of the hydrocarbon group determines the alcohol. Let's see, I want to refer you to a table in the very back of your book. Inside cover, you've got some tables, but the facing page, left-hand side, inside cover, the kind of the thicker page, has a listing of all of these organic molecule base type structures that we're looking at. You can see on there the alkene, alkane, alkyne. Not really in that order, okay, that we've already talked about. Alcohol's up at the top, okay. And so with the alcohols, let me get my pen back and draw a few and talk about some naming practices. So we have an alkane called methane, right? These are hydrogens, hydrogen, 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 hydrogen. But if on any of these, it doesn't matter which one, we often stick it here as if we were on, trying to write on a line of paper or something, but it could go here or here or here. If we stick a hydroxyl unit or group, sometimes people call it groups, okay, but anyway, we stick a hydroxyl unit. This has now become an alcohol, and you name it methanol, okay? It was methane, all, methanol. So you drop the E and you add OL on methane. We can do the same thing to ethane, and now you have ethanol. We can do the same thing to propane, and now you have propanol. And then depending on where this goes and all of that, you get something called, it's actually make that into, it turns into a branched chain thing, which is kind of weird looking. You have isopropanol. So if rubbing alcohol, this is not the actual structure for that, but it's a isomer of this, okay, a different arrangement of the carbons. But this is propanol, related to isopropanol. Okay, so you put 4 carbons, you've got butanol. Okay, and again, like this, where you put the alcohol, you can have, you know, 1 butanol, 2 butanol. You can't have 3 because if it's here, it's 2 as well. So if you put, if we were to erase that and we were to put it over here, that would be 2-butanol. It doesn't matter if it goes here or here, or if we turn it around and go here or here, because we start counting, this is our functional group, so we start counting from the end closest to it, so it'd be 1, 2. If I had it on, like down here, for example, 1, 2. Okay, so that would still be 2-butanol. Okay, so that's how you name those. You always have to tell where those functional units, those added units are stuck on. With the last presentation, I did it with a methyl group. Okay, but here we're looking at the hydroxyl groups because we're looking at specifically alcohols. And that carries on to, yeah, however many carbons you've got out here. Okay. Let me get that. There we go. Okay, so that basics of alcohol. I mean, obviously you can see that these structures can get much more convoluted. We can attach them to all sorts of other things and things get real complicated, but this is not a full-blown organic chemistry class. This is introductory to these structures and their families. So we're just getting the base picture here. So ethers are next, and they have 2 functional groups joined by an oxygen. Okay, so let me try to find in your book the page number to refer you to, so you can look at these in greater detail. And the alcohols, by the way, are on section 12.2, which starts on 391 of your book. Okay. And then the ethers start on 394. Okay. So for this, simply put, you're going to have a carbon group here and a carbon group there, and we could have a whole chain of carbons over here, a whole chain of carbons over there. They don't have to have the same number of carbons in each group. They can get all branched. It can be weird. So that's what R stands for. It stands for just there's this, it's a functional group here and a functional group there. Okay, the prime means they don't have to be the same. So this is a ether. If we were to just leave it at that and put our carbons with hydrogens, just 2 carbons, 1 on each side. This is a methyl group, right? And this is a methyl group. So what we have is we have 2 methyl groups. And so we're going to use the term di. So this is a di-methyl, meaning 2 methyl groups. Okay. And ether. Everything with a structural end in ether, it's 2 words usually. There might be some that are traditionally compounded, but I don't know of any. This is separated, dimethyl ether. Okay. Mostly on the test on this, when we get to this level of the organic structures, I'm not asking you to name uh, really anything beyond this. What I will give you is I will give you structures and I will ask you to tell me what group they belong to. And so what you need to do is recognize that any any number of carbon branching I've got going on over here, since that won't be the name of what I ever mess with here now. Okay. Um, yeah, I mean this week it could that's a C, sorry. This could get crazy. Okay. Uh, and then, there might be anything over here. Uh, so you see that and it's like, oh, I've got some carbons here. I've got some carbons here. They're on both sides of an oxygen. That's got to be an ether. Okay, that's what you got to recognize. I won't ask you to try to name this thing as, um, I don't know what that would be. Okay, I just made something up real fast. Probably doesn't even exist. Um, so it would have been an ethyl something or another. Okay. In that you do name them. If I were to do that, I don't like I said, don't anticipate. I'm thinking, I think maybe last year we had some, or the year before we had some extra time in class, which see, we don't really have that this year. Um, I think I gave some bonus for being able to name some of these structures. And so this would have been a ethyl methyl ether. Okay. You got a methyl group here, an ethyl group there, and I didn't do crazy branchings for the naming stuff. You put them in alphabetical order. Okay, so ethyl goes in front of methyl. So ethyl methyl ether. Um, could have methyl propyl ether, ethyl propyl ether. See, ethyl propyl. Um, uh, the methyl was there before methyl propyl. So whatever alphabetical order comes first. So that's how that naming happens. Again, don't anticipate actually doing that to you, except maybe putting on there as a bonus opportunity or something like that. But we won't get into much of that. The main thing is to identify groupings, identify the organic groupings. Okay. What family of organic molecule we're looking at. Okay, so probably move on here one more maybe. Let's see what it is. Get my screen back. Aldehydes and ketones. Okay, I think I do not know where my time is on this. I think that may be enough. And I think I'll break here, come back and handle aldehydes and ketones together. And uh, let's see, yeah, okay. Probably do those four together. Aldehyde, ketones, organic acids, and esters. All right, all together. And then probably break it into yet another one. So we'll see you back on the next one.